Hello everybody. In this video, we are going to find the Fourier series for the rectangular waveform given, and along x-axis we have the time and along y-axis we have the amplitude given for the particular signal x of t. We are going to solve this problem in step by step. So we go through the first step. It is to find t, the particular period of the signal. Usually a single period t is actually marked for a particular pattern, right? After that it gets repeated. So we usually start from the 0, then up to this we have the period. So here you have this one value, maximum value, then it is going downwards, then -1, then it is going upward, crossing the 0, again you reach the highest peak, highest value, then here it ends. Okay, so this is the end point. So up to this, you have this time period t. So it is from 0 to 4, isn't it? Time period is 0 to 4. But for performing the integration for this trigonometric Fourier series, we prefer to have this period from this negative value -1. So we start from this, okay, the 0, then it is rising, then it reaches this positive value, then it is coming down, again reaching this, then it is we reach this point, that is -1, again it is reaching this 0 point here. Okay, so this is a complete pattern, right? This is a single pattern. Here we have negative half cycle, so we have this positive half cycle as well as this negative half cycle, that is taken as one complete cycle, for which we can have this t. So t is equal to, it is the time axis where we are getting the single pattern. So it is starting from -1 to 3. Okay, so how do you calculate this t? So this t is equal to 3 minus of -1. So it is equal to 3 plus 1. So that is equal to 4. Already we know this, right? T is equal to 4. But why do we prefer this -1 to 3? So when we do the integration, we'll be getting minimum number of integrals. Otherwise, we will be having more integrations coming. So after calculating this t, that is the time period, you can go for finding the fundamental frequency. So you can write this omega naught. Omega naught is nothing but 2 pi f naught. But what's the relationship between this f naught and the t? We have the inverse relationship, isn't it? So here it can be written as 1 by t. So this is 2 pi. Instead of this f naught, we are going to substitute it as 1 by t. So that 1 by t is nothing but 2 pi by t value is 4. So it is coming as pi by 2. So what is pi by 2? Pi by 2 is omega naught. So we got two important things. This can be taken as equation number 1. This is result number 2, or equation number 2 for this particular problem. The step 2 is write down the Fourier series. It is the general Fourier series that we can write. So what it is x of t, that is equal to a naught plus, then we have the summation over the series, right? So it is n equal to 1 to infinity, then you have this an cos n omega naught t, then plus bn sin n omega naught t. This is your series. So for our case, we can write it as this x of t, it is equal to a naught plus sigma n equal to 1 to infinity, and then an cos n, instead of omega naught you can substitute it as pi by 2 into t, plus bn into sin n into pi by 2 into t. So we have made a single substitution of the omega naught value into this Fourier series formula or equation. Omega naught is equal to pi by 2 for this rectangular wave we had. Then we need to evaluate this x of. So what is the x of t value actually? So it is actually varying. The amplitude is varying. So it is varying from this -1 to +1. It has the swing. Okay. So once you evaluate this x of t, then only we can find out or evaluate the coefficients, right? So this x of t is equal to 1 within the period that we have taken. We have marked this period for our evaluation as t, that is varying from t is varying from -1. So the time period is 4. Time period is equal to 4. On that case, the t is varying from -1 to 3, isn't it? So there I can take it as two separate portions. So from -1 to 1, you have this positive 1 value. So this x of t is equal to 1, that amplitude is equal to 1 for t lies between 1 to -1. Similarly, the x of t value can be written for this negative portion, right? This portion. So for this negative portion, its value is -1. So the time period is from 1 to 3. The x of t has the amplitude of -1. So you can write it now as -1 for the time period t lies between 3 and +1. This is -1. Okay. Our next step Our next step is to find the A naught. So I must have explained you what are these things. This A naught, AN, BN or the coefficients of Fourier series. Coefficients, they will be some constant value, right? So the fourth step is to find out this A naught, the coefficient. It is nothing but a DC value. It is a constant value. It's a DC of this particular signal. Okay. So how to do that? For that we have this formula, that is 1 by t integral t naught to t naught plus t x of t dt. So we'll do this integration. So what's the value of this t? So this t, for that you can write it as 1 by 4, isn't it? It is 4. Then integral, this t naught actually starts from this -1 to 3. Okay, -1 to 3. The x of t values we have to put. So this integral value can be divided into two parts, like 1 by 4 integral -1 to 1 x of t dt plus then 1 to 3 x of t dt. So that is equal to 1 by 4. This is integral -1 to 1. Within this period, we know that this x of t value is positive 1, okay, plus 1 into this dt plus this 1 to 3. In that period, this x of t value is equal to -1. That's how we have evaluated this x of t. So it's nothing but 1 by 4. So it is simply dt, isn't it? 1 into dt is dt. So for dt, the integrated value is t. The time limit is -1 to 1. The upper limit is +1 and the lower limit is -1. Then here you have the minus dt, isn't it? So it is minus t, that's it. With the limits is 1 to 3. This is equal to 1 by 4. Now we apply the limit. So here it is for this particular t, what is coming, it is 1 minus of this lower limit. Then for the second term, for this t, if you substitute it, it is 3 minus this 1. So what happens here? It is 1 by 4. 1 minus of -1 is +1. Minus 3 minus thing is 2. So this is equal to 1 by 4 into 2 minus 2. So that is equal to 0. So we have evaluated the A naught, the DC constant value or the coefficient That's the first term in the Fourier series as 0. Okay, so we got one answer. Now we go for the next step. It is to find this an, the second coefficient. Okay, that is the coefficient of the second term. Formula to find this an is equal to 2 by t integral this t naught to t naught plus t x of t into cos n omega naught t into dt. So here we need to substitute this omega naught is value, isn't it? As well as we have to put this t naught plus t, and then this t. These things we have to substitute. Then we can go for performing this integration. So an is equal to 2 by 4 integral over the time period 1 minus 1 to 3 x of t into cos n. Instead of omega naught, you can put it as pi by 2. Already we have found it, right? So this thing we can do. So this an is equal to 1 by 2. Then this integration can be separated into two integrals. So it is minus 1 to 1, where you have the x of t value can be written as plus 1. So it is plus 1 into cos of n pi by 2 t into dt plus the second integral is with the limits 1 to 3, where this x of t takes the value minus 1. So it is minus 1 into cos n pi by 2 t into dt. So this can be rewritten as an is equal to 1 by 2 integral minus 1 to plus 1 cos n pi by 2 t into dt plus integral 1 to 3. So that minus 1 comes, so that you can change this sign as minus. Okay, we are taking it outside with the cos n pi by 2 t into dt. So now you can perform this integration. It is 1 by 2. When you perform integration, it comes as sine n pi by 2 t divided by n pi by 2 with the limits minus 1 to 1, then minus. For this we can again write this as sine n pi by 2 t divided by n pi by 2 with the limits 1 to 3. Apply the limits. So this is equal to 1 by 2, and in the second term we have this n pi by 2 as common, so it can be taken outside into 1 by n pi by 2. So this 2 and 2 get cancelled, right? So that it can be written as 1 by n pi. So within this we have sine n pi by 2 t with the limits minus 1 to plus 1 minus sine n pi by 2 t with the limits 1 to 3. So this is equal to 1 by n pi. So when you apply limits, then it becomes sine of n pi by 2 into 1 minus, then applying the lower limit, sine n pi by 2 into minus 1. Okay. This is for the first term, we applied the limits. Then for the second term, we can apply the limits like this minus of sine n pi by 2. Instead of t, you can apply it as 3, right? Then minus, here it is sine of n pi by 2 into t value is 1. So this can be written as 1 by n pi. So this is sine n pi by 2. Sine of minus x becomes minus sine x. So it is plus sine n pi by 2. Then here you have the second term minus of, within this we can do the, okay. So it becomes sine of 3n pi by 2, then minus sine n pi by 2. So what happens when you do the multiplication with this minus within this bracket, then it becomes minus sine 3 n pi by 2, and this becomes plus sine n pi by 2. So I am changing this signs and all. Okay, so this becomes plus. So here you have one sine n pi by 2, again one sine n pi by 2, here also you have sine n pi by 2. So three terms are there, right? So we can write it as 3 times. So it is 1 by n pi, then 3 times sine n pi by 2 minus sine 3 n pi by 2, this term, right? Okay, so we have got one final expression for this an coefficient. Now the thing is, we have to look for what's the value for this an, right? Actual value. So we are going to find out the coefficient values. For that, we take it as even and odd values. So we can consider first the even value. This is case 1. You consider even values. So even values are considered from 2 only. 2, then 4, 6, like that it goes on. Because if you have look at this series, actual series, see here it is from n equal to 1 to infinity. So it doesn't include 0. Okay, so when you have this even values 2, 4, 6, like that only you have to consider, no need to include 0. So simply you substitute the value as n equal to 2, then what happens, a2, that is equal to minus 1 by 2 pi, right? Just substituting in place of this n, wherever you have n, into this general equation, okay, which we have just now got, right? So it is 3 times sine, value is 2 by 2 minus sine 3 into 2 pi by 2. So you can cancel out these things, right? Sine pi, this becomes 3 pi. So it is equal to 1 by 2 pi, then 3 sine pi, 3 sine pi minus sine 3 pi. So we should know the values of this, right? Pi is what? 180 degree, right? So sine 0 is equal to 0, sine 90 is equal to 1, sine 180 is equal to 0, and sine 270 is equal to minus 1. Those are values. And if you write it in terms of pi, how do you write it? Nothing but sine 0 is okay. Then here you have to write it like sine pi by 2, that is equal to 1, sine 2 pi, sorry, sine pi, that is 180, that is equal to 0, sine 3 pi by 2, that is equal to minus 1. Then the last one is sine 2 pi actually, right? That is equal to again 0. So what is sine 2 pi value? It is nothing but 360. That is also 0. So sine 360 and sine 0 are the same, right? So this cycle repeats 0, 1, 0, minus 1, 0, like that it comes. Similarly, they're just the opposite for this cosine values. Cos 0 is equal to 1, cos pi by 2 is equal to 0, cos of pi, that is equal to minus 1, cos of 3 pi by 2 is equal to 0 again, and cos of 2 pi, that is equal to 1 again. Okay, so this is how we need to substitute the values. So if you take this as, if you consider this a2 value, that is 1 by 2 pi 3 times, what is the value of sine pi? Sine pi is, here it is 0, right? 180 degrees, so it is 0, minus sine 3 pi is also, it can be written as 2 pi plus pi, isn't it? I sine 2 pi plus pi means we will be getting again as sine pi. 2 pi plus pi becomes pi. That you must be knowing the trigonometric formula. So that is equal to sine pi. So sine pi value is what it is? It is sine pi. The sine 3 pi becomes sine pi. But we know the sine pi value is nothing but 0. So here we get the final answer for this A2 as 0. So we have evaluated one value. Now we need to evaluate A4. So for this case 1, where this signal is considered as even, that n value is considered as even, and we need to evaluate this an. We have already evaluated a2 as 0. Now we move on to this finding a4. So that is 1 by 4 pi. That means n is equal to 4. So here it is 3 sine 4 pi by 2 minus sine 3 4 pi by 2. So it becomes 2 pi. Here also it is 2 pi. Okay, so it is equal to 1 by 4 pi. Then here it is 3 sine 2 pi minus sine 6 pi, isn't it? So it is 1 by 4 pi. So what is the value of the sine 2 pi? It is sine 360, again sine 0. Sine 0 is 0 minus this 6 pi is also 3 times that 360 value, isn't it? 3 times this 2 pi value, isn't it? So it is, we get the 3 revolution, right? So it is nothing but sine 2 pi again. So the sine 2 pi value is equal to 0. So it is 0 again. So a4 is 0. The same way, if you evaluate for this a6, it also becomes 0. So we come to an understanding this an, when n is equal to e1, that values are 0. Okay, that is case 1. Now we move on to find out the case 2, where we consider n as odd values. So odd values means we have to find it for 1, 3, 5, 7, 9, 11, like that it goes on. So what is the equation for this an? An is equal to 1 by n pi what's the equation for this? What is the expression for this an? An is equal to 1 by n pi 3 sine n pi by 2 minus sine 3 n pi by 2, isn't it? So for odd values, we substitute n as 1 now, so that it is a1, that is equal to 1 by pi. So 3 sine pi by 2 minus sine 3 pi by 2. So this a1 is equal to 1 by pi. 3 into sine pi by 2 is 1, isn't it? Sine 90, right? That is equal to 1 minus sine 3 pi by 2. That can be taken as 3 into 180 by 2, right? So it is 90. So 3 into 90, it is 270, isn't it? So what is the value of sine 270? Sine 3 pi by 2. It is minus 1, isn't it? So we get this as minus 1. Already one minus sign is there. Again minus of minus plus. So we get this like this. So it is 4 by pi. This a1, we got some values, right? It is 4 by pi. Then we can find out this a2 value. So we can find out this a3 value. So in a similar way, a3, because n equal to 3, then a3 is equal to 1 by pi 3 pi. So we can substitute it like an is equal to 1 by n pi. In n you can substitute as 3, so it is 3 pi. Then 3 sine n pi by 2, so it is 3 sine, in place of n you can put it as 3 pi by 2 minus sine, this one you refer this, okay, sine 3 times the n value is again 3 pi by 2. So this is equal to 1 by 3 pi. Then here you get this as 3 pi by 2. I have already told you that it is 270, so its value is minus 1, right? So it is minus 1 minus, it is 9 pi by 2. So 9 pi by 2, that can be written as 4 and half, right? 9 by 2 pi means it is 4 and half. 4 and half means 4 and half pi. So it is 2 pi, again or 2 pi. So it is 4 pi plus 1 half pi. Half pi is pi by 2. Like that you can write. Okay. So 2 pi plus pi by 2, again you are getting pi by 2. So this is over. Again 2 pi plus pi by 2, it becomes pi by 2. So it is only sine pi by 2. So sine 90 values how much? It is 1. Okay. Sine 90 is 1. So what's the answer you get for this? 1 by 3 pi into minus 3 minus 1. So it becomes minus 4 by pi. So this is the value for A3. The same way, if you repeat it for A equal to 5, so same way for this odd value n equal to 5. The same way you can do it for n is equal to 5. So an becomes a5, that is equal to 1 by 5 pi. Okay, then you will be getting this as 3 sine n pi by 2, that means 5 pi by 2 minus sine 3 n pi, n is 5. Okay, so 3 times pi by 2, 5 pi by 2. So the thing is the same. So here you get this as 3. This becomes 1. Okay. 5 pi by 2, that can be written as 2.5 pi, right? So 2 times pi plus 1 half, isn't it? So this 2 pi plus pi by 2, that becomes pi by 2. So sine pi by 2 is sine 90. Sine 90 value is equal to 1. So it is 3 into 1 is 3 minus. Similarly here you will be getting this is, it is 15 by 2 pi. 15, that is 7 and half. 7 and half means we can write it as sine of 6 pi plus 1 pi plus another half. So 7 and a half, right? So this 6 pi, you can leave it. Pi plus pi, okay. So that is 3 pi by 2. It's nothing but here 180 plus some 90. So it is 270. So sine 270 means it is equal to how much? Minus 1. So minus of this minus 1, the sense it becomes plus 1. So it is again 4 by 5 pi. So what is this value? This is an. That means a5. That is equal to 4 by 5 pi. The same way, if you evaluate all the values, then we come to know that this a1 is equal to 4 by pi. Then this a3 is equal to minus 4 by 3 pi. Then a5 is equal to 4 by 5 pi. Then when you go for this a7, that is equal to minus 4 by 7 pi. a9 is equal to 4 by 9 pi, like that it goes on. So we can come to some common thing, right? Like an is equal to, here you see it's coming as 4 by pi, then again here also 4 by 5 pi. Here also it is coming as 4 by 9 pi. So it is for A1, then 5 and then 9. So the value is, in general you can write it as 4 by n pi, where this n is equal to 1 comma 5 comma 9, like that it goes on. And when you look at this, a3 value will be minus 4 by 3 pi. So here you have this 3 and 3. Similarly, you can refer this is 1, right? 5, 5, 7, 7, like that it comes. Okay. So it is minus 4 by 3 pi. Then when you refer this, a7 is equal to minus 4 by 7 pi. So this is equal to minus 4 by n pi, when n is equal to 3 comma then 7 comma this 11, like that it goes. Okay, so this is the answer for this an, the coefficient an. Okay, the same way we can evaluate for this bn also. So it is a long process. So what is it for this bn? Bn is equal to, so bn is equal to 2 by t. What's the general formula? 2 by t integral t naught to t naught plus capital T, this x of t into sine n omega naught t dt. That way we can find out this bn coefficient. This 2 by 4, this integral is from minus 1 to 3, and then we have to substitute this x of t value anyhow. So instead of this, we can put it as n pi by 2. Okay. So here you will be getting this as 1 by 2, and this integration can be divided into two things, like minus 1 to 2, where you have this one value for this x of t. Okay, 1 into sine n pi by 2 t into dt, then plus it is 1 to 3. This x of t value is there, it is minus 1 into sine n pi by 2 to dt. So this can be evaluated now. 1 by 2 sine n pi by 2 t, that can be integrated as cos minus cos n pi by 2 divided by n pi by 2 with the limits minus 1 to plus 1. Then here we have this plus sign. For this it is minus into plus, right? So you can write it as, it is minus of sine n pi by 2, again it is minus cos n pi by 2 divided by n pi by 2. But this minus and this minus, it is getting cancelled, and so you get it as plus. So with the limits here as minus 1 to plus 1, isn't it? When you take this n pi by 2, which is common for these two terms, then you can bring it outside, so that you will be getting this as 1 by 2 into n pi by 2, that 2 get cancelled, so it is 1 by n pi. Already I have told you there, right? It is t. Okay, so for this case it is by applying the limits, it is cos 1, that is cos n pi by 2, when you apply positive sign, positive 1 plus 1 cos n pi by 2, then this minus of cos minus n pi by 2 like that we can write. Then plus, here comes the second term with cos n pi by 2 minus the lower limit with cos minus n pi by 2, because minus 1 we are applying. This is for the second. Okay, so this is equal to 1 by n pi minus of this cos n pi by 2. This cos of this minus n pi by 2 is nothing but cos n pi by 2. Okay, the sign can be removed. So minus cos of n pi by 2. So what happens here? These two get cancelled. The first term is over, right? It is 0. So when you come over here again, what is happening here? Cos of n pi by 2 minus this cos of minus cos n pi by 2 becomes cos of n pi by 2. Okay, so cos of n pi by 2. Here also these two get cancelled. That means it is 0. So no need to find the values because bn after integration and applying limits becomes 0 on the whole. Okay, so shall we summarize the answers now? So what it is, a naught value is how much? A naught is equal to 0. That coefficient is equal to 0. Then what it is for, so after finding this coefficients we can write the triangular Fourier series for this rectangular waveform like x of t is equal to a naught is 0, so we are not including it. Sigma n equal to 1 to infinity, this an alone is present, an cos n pi by 2 t, isn't it? That alone is present, but the actual values we can substitute and you'll get it. The series is 4 by pi cos. Okay, this an is equal to 1 now. Okay, so a1 is 4 by pi cos of n pi by 2, n is 1, so it is pi by 2 t. Then the n value is 3. For n value is 3, it is minus 4 by 3 pi cos of 3 pi by 2 t. Okay, then we have the fifth one. Okay, n equal to 5, so it is plus 4 by 5 pi into cos of pi by, that is 5 pi by 2. என்ன என்ன சொல்றாங்க, முடிச்சிட்டேன். 5 pi by 2 t, then minus again 4 by 7 pi cos 7 pi by 2 t. So like that it goes on. So this is the final answer for our case x of t, that is the Fourier series for rectangular waveform. Okay, in this if you want you can take this 4 by pi outside, then you will be getting this as, so it is 4 by pi cos of pi by 2 t minus 1 by 3 cos 3 pi by 2. Okay, so we have the doubt in this representation of this Fourier series. Actually I have written like x of t equal to a naught plus sigma n equal to 1 to infinity a n cos n omega naught t plus bn into sin n omega naught t. So some people would be asking whether it is a naught by 2 or simply it is a naught. That doubt arises because some textbooks are using this as a naught and some textbooks are using a naught by 2. Okay, so which one is correct? Both the things are correct. The thing is, when you go for this integration, right? So when you go for this integration, a naught here in our case, okay, I haven't written it as a naught by 2. Instead, I have mentioned it as a naught only in the Fourier series. So if you have written it as simply a naught, then we have put it as 1 by t alone while performing this integration, 1 by t. But in the books, if they have represented as a naught by 2, they have started it with 2 by t. Okay, 2 by t integral t naught to t naught plus capital T x of t dt. So both are same, right? How?